Good morning. My name's Jason. I'm a product manager on Google Cloud. This is Dev 100. It's all about serverless technology. It's all the new things that we've done in the past 12 months. I have a lot of content to get through, so I'm going to whiz through it super quick. Some of it may not be that clear. If you have questions, I'm going to be loitering around over there afterwards. We have to get everybody out at the end for the next group to come in, but I'll hang out over there if you have questions, because we've got a lot to get through. One quick bit of admin. There's an app, there's a rating. Please rate so I know just how terrible I was and I can improve for next year. OK, serverless on Google Clouds. It's more than just compute. The intent is that you can build end-to-end applications without ever having to touch a server. But for today, we're just going to focus on the compute portion. And in GCP, serverless compute consists historically of two products: App Engine, which has been over 10 years in development, which is a platform as a service, great for building web apps. Cloud Functions, which is only about 3 years old, is the functions as a service platform. Our definition of serverless, for the record, is two dimensions or two main criteria that a product must achieve in order to be classified as serverless. One is that you don't manage the infrastructure. We are the ones that carry the pager at 3 o'clock in the morning when things are on fire. And the second criteria is that you pay only for what you use. If those two things are true, we can consider it serverless. So traditionally, App Engine and Cloud Functions. The more recent entrant is Cloud Run. We announced the GA actually in the keynote, but secretly we had a GA of that last week. So it's 1 week old as a generally available tool. And it's our serverless platform for running containers. It comes in two flavors. There's the fully managed, what we call the fully managed version of Cloud Run, which runs on GCP. And then you can also have Cloud Run for Anthos. For today, we're going to focus on the fully managed portion of it. There's another session, which I believe is tomorrow, Dev 101, which goes into a deeper dive on Cloud Run on both versions. So if you're interested in seeing more of the Anthos side of it, then I recommend you go and see that. Just a quick recap on what these products are for those who are not familiar. App Engine standard, traditional platforms as a service, source-based developer experience, so you just reason about your source code. It's mostly oriented around apps. So an app would be Node, Express, Java, Spring, Python, Django, take your pick. We support all the popular languages. And it does some clever things like automatic TLS termination, traffic splitting for doing blue-green deployments or gradual rollouts, and a bunch of other features. But that's sort of the app-based platform. Recently, earlier this year, we announced a new capability in App Engine, which is what we call second-generation runtimes. The earlier versions of App Engine back in the day had a model of producing language-specific runtimes that were curated by Google that had all the security holes plugged up and scaled very well and worked great in App Engine. But it actually was hard for us to keep up with the pace of the developer community in the evolution of these languages and these runtimes. So earlier this year, we announced second-generation runtimes, which is a new security isolation technology based on gvisor, a technology that we open sourced last year. And so now we are actually able to move much faster in terms of bringing new runtimes into App Engine. So the PHP 7.3, Go 1.11, Java 11 are all GA, and we have a range of the latest runtimes coming out. They're in beta right now, so Python 3.8, Node 12, Go 1.13, and Ruby 2.5. As I mentioned, what we could now call the first generation of App Engine, it's actually over 10 years. And 10 years ago, 128 meg was a lot of memory. Now, try running your Java Spring app on 128 meg of RAM. So as part of this move to second-generation runtimes, we thought we'd just double those memory allocations. The price doesn't change. You just get twice as much memory because it's 2019. So that's good. quick recap on Cloud Functions. As I mentioned, the Functions as a Service platform, mostly oriented around event-driven computing. So individual functions can be bound to events that emerge in your cloud infrastructure. Also on the runtimes front, typically newer runtimes come to App Engine first, and then there's a little extra work that we have to do to bring them into Cloud Functions. So we're sort of one step behind, but we're moving at the same pace. So Python 3.7, Node 8, and Go 1.11 are all GA, and we have Node 10 and Go 1.12 coming through next. Oh, and also Java. We're also rolling out new regions for Cloud Functions. When we launched, or shortly after launch, we had these 4 regions, 2 in the US, 1 in Europe, and 1 in Asia. We have 3 new regions right here in London, Hong Kong, and another US region. And I mentioned, I told you I was going to whip through it. I'm going as fast as humanly possible. I mentioned Cloud Run. Cloud Run is new. It's GA now. And it's our platform for running serverless containers. It actually shares a lot of underlying infrastructure from both App Engine and Cloud Functions. It supports any language runtime because it just takes Docker images or OCI images. We also do the auto provisioning and termination of TLS connections, or provisioning of certs and termination of connections. It supports event triggering through PubSub, and it's fully serverless, so you don't manage your infrastructure. It has fast auto-scaling. We have a demo of that a little bit later. And you only pay while your code is actually executing. That's all very confusing. The one thing that you just need to remember is that Cloud Run runs containers. So this is what it looks like at the command line. This is a simple example of deploying a container. So there's one command, gcloud run deploy. It takes a container image that you've already built, however you've built it. And then it will deploy that to the infrastructure. We'll create a version of it that we call a revision, and we give you back a HTTPS URL. You can then, if you like, add your own domain to that URL. So I whizzed through a bunch of words, but let me show you what it actually looks like. I just have a very quick Hello World demo. Switch to demo, please. OK. So usually what I would do is I would have a contrived demo with a bunch of things that I have in text files that I can quickly copy-paste in and pretend that I wrote it on the spot. Given that this is just Hello World, even though I'm only a product manager, let me see if I can actually do this for real. So this is Cloud Console. This is just the home page. This is just an empty project that I created. The only thing I've done in this project is I just enabled the required APIs, the Cloud Run API. So this is the Cloud Run. There's nothing going on there yet. So I'm going to build a very simple Node.js Hello World. Apologies for using Node.js. As I said, I'm a PM. And because I don't want to be embarrassed by my terrible VI skills, I'm going to launch the editor so I can write text like a human being. OK, so what I'm going to do, I'm just going to open up Express. I already have it in my history. There we go. And I'm just going to run. I'm going to build this in a container and run it. It's just Hello World. It's nothing fancy. So I have a little. Can you all see that? Let me see if I can zoom in a little bit. That's a bit better. So I have nothing in there. I'm just going to do an npm init to create a new Node app. Yes, default, default, default. I'm going to create an index.js file. This is empty. And I'm literally going to copy and paste this sample from Express into there. The only thing I'm going to change is this port variable. Cloud Run requires that we use an environment variable that will be defined by the execution environment, so that it also runs locally. I will just also allow for 8080. And then the only other thing, I need a Docker file. Now, the one cheat that I do have is I have a Docker file here. For anyone who is somewhat fluent in Docker files, you'll recognize that this is a very bare bones, very simple Docker file, not much to it. It just takes the publicly available Node.js 12 base image. And then it's going to run this npm start command, which I will have to just tell my deployment descriptor here what to do. So I have my hello world. Let's just run that and see if it works. Whoa. I didn't install Express.js, which is the web framework that bootstraps the HTTP server. Okay, so let's just test that that works. I'm going to preview that right here, right now. Okay, so that's running. That's just running in Cloud Shell right now. So now I'm going to build my app into a Docker image. I have also, I lied before, I do have some cheats. So I'm going to use Google Cloud Build. Oops. This is just a special, this Google_Cloud_project is a special variable that is populated in Cloud Shell that just pulls my current project. So what that's going to do is zip up the source code in that directory, send it to Cloud Build. Cloud Build is going to recognize that there's a container image, a Docker file there, and it's going to build for me a container image. If I pop over to Cloud Console and Cloud Build, you can see it's building there. You'll see the one that I built before at 5:30 in the morning. That's jet lag for you. So it takes about 25 seconds, according to this. So there it is, it's done. So I'll pop back over here, and now I'm going to go back to my cheat sheet, and I'm going to deploy that container image into Cloud Run. I haven't set up any cluster. There's no, all I did is enable the API. So it's creating a revision. It's going to route traffic. The Cloud Run supports a traffic routing, a traffic splitting model similar to App Engine. And then it's going to do a bit of IAM stuff, which is already done, actually. This just takes a few seconds. And if it doesn't, I'm just going to blame the Wi-Fi. Actually, even though I have Ethernet. That doesn't work. Okay, by the time I get back, it'll be done. There we go. And so now in Cloud Run, we will see there's my hello world. If I click on that, you'll see that out of the box, I get some metrics. These are piped into Stackdriver. I can see all the revisions of my service. I only have one revision. I can get logs. If you really want to get dirty, you can look at the YAML. I don't recommend it. And then if I click my URL that I'm provisioned, there's my hello world. OK, back to slides. OK, that's hello world. So next, I want to invite onto stage a customer who's using Cloud Run, MarktSaturn. So Mathias and Fabian have volunteered their time to come talk to you about what they've been doing with Cloud Run. So please welcome Mathias and Fabian.
So, hello. You won't believe I'm the guy on the right side. So, Jason, thank you very much for providing us the opportunity to talk. Maybe I start with a few words about MarktSaturn. I think we are not so popular in UK, but we are the biggest consumer electronics retailer in Europe. We are present in 14 countries. We have more than 1,000 stores. And we have, meanwhile, not so bad online business. So it seems like we are doing more than 12–13% of our revenues in the online market. Overall, we have 62,000 employees. And you would say we started around about 30 years ago. And like everyone, we had the same challenges, historically grown application landscape. I think you all know what that means. And a lot of pressure from outside, so the market is changing, the customer behavior is changing, and then we had the challenge, how we have to innovate, we have to change. And this is where we started to talk about what should we do. And Google was one of the innovation drivers on our side, so we started in 2017 to do some proof of concept stuff. And finally, we agreed at the very beginning of 2018 that we very strongly partner with Google. And we started an internal platform to provide Google capabilities to all our internal developers. It took us 5 months to have the first service in production. It was an online webshop service. So we created a complete vertical. The webshop was built new, single-page application approach, cloud native. And behind the scenes, we fully relied on Kubernetes and created this whole vertical in 5 months. Then we scaled a lot, and after we somehow finalized all this application development stuff, we started to create a second area where we focus more on data analytics and all this machine learning and AI stuff. So this is what we started this year, and I personally changed from the cloud platform side to the analytics area at the beginning of this year. This is our journey, and to say you can see all these numbers, we are having a lot of Kubernetes clusters, we have a lot of Docker images, we have nearly 60% of our internal developers onboarded on cloud. But using GKE, it really pushed us forward, but it finally lets you to do a lot of stuff besides. I think you all know you have to take care of these specify volume of a Kubernetes cluster. You have to take care of all these network connectivity issues. So we are using a partner interconnect. And at the very beginning, when we started our journey to cloud, you can imagine that most of our applications were somehow placed in our legacy systems. And now we have to make them available in the cloud. So this triggers a lot of network infrastructure and security challenges. On the other side, Kubernetes doesn't scale to zero, so you always have this white noise cost. You're always consuming some money. And you have to understand what you are doing. So you have to understand Terraform, you have to understand all this Kubernetes stuff, you have to understand this network, IP forwarding, NAT gateway, all this stuff finally, to really manage a production-ready application in a very hybrid context. But we started with Cloud Run a few months ago, and we have the big advantage that we now have a lot of stuff of our legacy world already available in the Google Cloud world. And so we thought, what could Cloud Run bring us? And from a technical perspective, it's like Jason said, you saw it just in the Hello World application. So it's pretty simple to ramp up a new application. It scales better. We have a better portability of our images. We have a better testability and increased flexibility to provide, finally, business use cases. And from a management perspective, it's also very interesting because you have less effort, you have a faster time to market, and finally, the expectation was that we reduce our costs. Now, Fabian will present you a real production use case, how we use Cloud Run at MarktSaturn.
Thanks, Mathias. So, what I would like to present is maybe the most famous use case we're currently having. It's a real-time sales dashboard. We have an omni-channel business, we have a web shop, and we have over 1,000 stores. The goods management system that is running within our stores is kind of, let's say, old-fashioned and kind of legacy, so therefore it's a huge challenge to create such a real-time sales dashboard. The business value behind that kind of use case is that we want to react as fast as possible to customer needs and behavior. If we have a promotion, we would like to know how the promotion is performing and maybe adjusting that promotion as the customer behaves on that. So we have basically 4 building blocks within that architecture. First is getting the data out of our decentral databases in the over 1,000 stores, passing in that via Kafka. The Kafka is running on GCP. Then fetches the data via a Cloud Run service from Kafka and passes it to PubSub. Then we have 2 different streams. The first one is a raw historization stream of the data to have the data in BigQuery for any other use case for the future. And also, and this is maybe the most important thing, is to have the operative context. To calculate the real-time sales in stock based on multiple other information, for example, the product API and the outlet API, and then passes the data back to BigQuery, that then the sales dashboard that we create in Data Studio can be accessed by our C-level, by our store managers, and whoever wants to access that. So this is what we built there, and we really focused on Cloud Run there. And it was kind of very seamless to use that. After bringing that to production, we did a short recap and thought, okay, what was our journey with Cloud Run and what was the journey before? And this is what I want to go through right now. So we have split our developer journey in 4 different groups in the getting started, in setting up compute, CI/CD, and run. So within the getting started, you need to create a project with everything you want to use in GCP. Same with Cloud Run. So there is basically no difference. The interesting thing comes in with the next 2, so setting up the compute. So you need to set up the compute, you need to do some core infrastructure stuff, load balancing, service mesh, specify volumes, and some networking stuff. So with Cloud Run, it's kind of easier. You don't need to hassle with Terraform or whatever infrastructure provisioning tool you want to use. You don't need to focus on that overarching networking stuff what Mathias mentioned with the kind of high complexity with the on-prem interconnect stuff. And the cluster configuration is also not necessary. Only thing that you need to do is, of course, to set up how other product teams, how other services or customers can access your service. So after setting up the thing and then deploying it, you have the deploy time, testing, image repository, and some other stuff. We encountered there 3 big things that gets easier for us. First is deploying it. As Jason showed, quite easy. You pack your container, push it to the cloud builder, for example, and then it's done. Also the testing, it's very easy. You don't need to hassle around with Helm, Puppet, or Jenkins or so. It's really seamless, and you can focus on your business requirements and your business codes. So this is everything is green. Green is good. So therefore, and finally, after you're having that solution, the app deployed, you have the run. So Cloud Run comes with a lot of predefined metrics that makes it very easy to get a sense of how your app is performing, how the customers are using it, or what kind of things are really going around. And if you're then leaving the office at the evening, you can go with that default metrics very easily out and say, okay, I know what's going on, and set up the alerting with stack drivers, so everything okay. So this is kind of what was a very good feeling when we brought that to life. And yeah, it felt very, very good. So to sum that up, as also heard in the keynote, we did a comparison of previous go-lives with the go-lives, not only with that use case, but with also several use cases. And we've seen that we have an overall improvement of 8 times. So we are 8 times faster from the beginning of our application until it's available for our customers. And I would say this is kind of very impressive. And this hopefully shows you that Cloud Run is really an awesome tool to focus on your business and add value for your customers. Mathias, so beside that, we have also several more improvements that we get out of Cloud Run.
Yes, so next to the time to markets, until now in production we had no incidents, so it seems like we have increased stability. Due to the possibility that Cloud Run scales down to 0, especially overnight and so, the cost reduction is around about 40%, what we see right now. The overall efforts in providing a production-ready application over Cloud Run, it's around about 80% less. And you could say, summarizing everything, we have reduced complexity, even from a skill perspective. So if you think we were classically retailer, we were no technology company. We are transforming since 3 or 4 years. And you have to understand all these most modern technologies, especially provided from Google. So it's a huge challenge for us to bring all our developers in a cloud-native state. And maybe Cloud Run can simplify this education journey from our internal colleagues a little bit. And this means for us, we are more flexible, in addition, a little bit faster. Fabian.
Finally, how we adopted Cloud Run from a timeline perspective. So we've started with the first POCs in February, then defined the first use case where you want to use Cloud Run. Then we've seen the announcement of Jason in San Francisco. And afterwards we said, OK, let's use it in production. And we went live on a month later with a private alpha of the first MVP. And after some time, we said, OK, everything that is built new from now will be built with Cloud Run. And this was our journey. And we're looking forward for every new feature and for the insane cooperation we have with Google and with you, Jason.
So, thank you very much.
Thanks.
Thanks very much. Thank you. Thank you, Fabian and Mathias. OK, we're going to zip through the last section, running out of time. So, new features. Some of this is a little bit complicated. I'm going to zip through it again. I will be over there at the end if we have questions. OK, first feature. At the top right-hand corner there, I have a little hieroglyphic code system that just tells you which of the 3 products I mentioned this feature applies to. So this has been an App Engine for a while, but it's not new, so that's why it's grayed out. It's new for Cloud Functions and for Cloud Run. Scaling controls, maximum instances. It's great to have auto-scaling, so we'll scale up to thousands of instances, and time permitting, Ben will show you a demo of that. But what happens if you don't want that, if you had some rogue bit of code that went into a loop and scaled you out massively, and then you get a big bill from us, and that's great, but maybe you didn't want that. So what you can do here is impose a maximum instances, so you never go above a certain limit. Also useful for impedance mismatch scenarios. So again, if we give you the power of auto-scaling, but your tiny little database can't handle all those connections, what do? Here's an example of this. Request comes into the front end, more requests come in, and we scale up instances. Well, the max instances line will ensure that you never go above a certain limit, and requests that come in after that will be queued for a certain amount of time, and eventually they will time out and back to the client. But the good news is that your tiny little database doesn't keel over under the load. So that's max instances. Next feature, Serverless VPC Access. Serverless is great, but sometimes you also have infrastructure on virtual machines. Perhaps you're running your own Elasticsearch cluster, and you need to talk to it from the serverless infrastructure. In order to provide that, we have this Serverless VPC Access feature, which allows you to peer your serverless infrastructure with your VPC. It's a very simple command line. It's available in Cloud Functions and App Engine. It's coming soon. We're working on it for Cloud Run. It's not quite there yet. So what that allows you to do, as I said, imagine you had resources in a couple of different regions in virtual machines or in Kubernetes clusters. You create a VPC boundary around that. Then your serverless infrastructure through a connector can connect into that VPC. And then if you have stuff on premises, you can then connect all the way back down through a VPN to your on-premises data as needed. OK, per service identity. What this does is give each service in Cloud Run, I call it service, that's what we call it in Cloud Run, service or function, same thing. Gives each service its own identity. So you can have multiple services, multiple functions in a single GCP project. And with this feature, what you can do is give each one of them their own service account, their own identity. So that individual functional service acts as that identity whenever it's trying to access other resources. This means that you can lock it down to say, this function or this service can only read from that one storage bucket or can only access that one cloud resource. And it gives much better, much more fine-grained access control over who can do what in the infrastructure. Here's an example of why it's important. Let's say you had a function that reads from a cloud storage bucket. The function is going to have an identity. That identity is going to have a role. In order for it to be able to read that storage bucket, it needs permissions on, it needs read access to that storage bucket. So you grant that, and that's fine. By extension, the end user creating this environment must also have that role to be able to read from that bucket. Otherwise, there's a privilege escalation. So that's fine. We do that. And then let's say you had another function entirely that wanted to read from a totally different bucket. Previously, all the functions in the project would share the one identity. Now, this meant that you had the same situation here, where this other function had that same identity with the same role, and you need to give permissions on this other storage bucket for the second function. But it means you have this ability for the first function to access the second storage bucket, which may not be what you want. You have a very coarsely grained permission model. What you actually want to do is give that second function a different identity and give the second storage bucket a different set of permissions, and then you can't get that cross-access situation. Seems like a diversion, but Cloud Tasks is a separate product in GCP that falls under this serverless banner. You remember before I said the definition of serverless, you don't manage infrastructure, you pay only for what you use. Technically, this qualifies. It's a queuing system. It's great for this situation where you have a series of sequential or synchronous tasks. One of them, perhaps, is a really heavyweight task, and it's slowing everything down. And you might realize that, well, this one task, maybe it's sending an email, maybe it's writing to a database, whatever it's doing, doesn't need to be synchronous. It doesn't need to be in process or in line with the request. So you might want to push that out into an asynchronous process. But as soon as you do that, sometimes if you just spawn a thread and do it asynchronously, you may lose some reliability guarantees. What if that task fails? You want some sort of retry semantics. You want at least once guarantees. So Cloud Tasks is a great way to do that. You have a configurable retry policy. You can configure rate limits if you're going to a back-end system that has a limit on it. And there's other criteria around scheduling and pushing to HTTP. Here's an example of that. Let's say you had requests coming in, similar to that impedance mismatch scenario I was talking about before, requests coming into a function and overloading your database because it couldn't deal with enough. Well, what you can do is put a queue in between there, and then you can start declaratively defining things like rate limits and retry policy. So if the database is not able to respond, that task will eventually succeed through retry. Cloud Scheduler is the sort of the twin of Cloud Tasks. Its job is cron as a service, simplest way to think about it. Schedule things on a clock. Has many of the same features as Cloud Tasks. In fact, it shares a lot of the same infrastructure. You can schedule things to repeat. You can have them run once in the future. And it also pushes directly over HTTP. So these work great with Cloud Functions, App Engine, and Cloud Run, but actually it's just arbitrary HTTP. You can use both of those against any other HTTP service that you may have. And it uses IAM, Google IAM, for authentication between them. OK. Moving on. More IAM. You can never get enough of it. One capability that's relatively new that we have in Cloud Run and Cloud Functions is IAM on what we call the data plane. So we have a distinction between data plane and control plane. Control plane is where you perform operations like create this service, delete this service. The data plane is actually where data is traveling. So we allow you to specify IAM policy basically on your HTTP endpoint. What this does is gives you the ability to create sort of quote-unquote private services that aren't visible to or aren't invocable by the outside world. And it uses the native IAM capabilities in GCP to do this. It's a very simple one command. So coming back to Cloud Tasks and Cloud Scheduler, here's an example of that IAM identity in operation. So Tasks and Scheduler are going to send the request to your service over HTTP. Well, how do you secure that? How do you know that your service was being called by Cloud Tasks? How does that data encrypted in transit? Cloud Tasks and Cloud Scheduler, similar to the per service identity I talked about before, will have their own identity. They will materialize an OpenID Connect token, send it on the HTTP request, and Cloud Functions and Cloud Run will validate that token for you. You don't have to worry about any of this. This all just happens. All you need to do is specify the identity and the permissions that you want. But it's extensible if you want to do your own HTTP service. You're just going to get a standard OpenID Connect token. And that also works with PubSub. And just a clarification, because we had a lot of IAMs going on. So per service identity is where you specify an identity for your Cloud Function or your Cloud Run service, and that affects outbound connections. So when you make a connection outbound to another GCP service, it will carry a bearer token for that identity. The HTTP, the data plane authentication I mentioned, is for inbound communication. So when you receive a request, that request will have an identity in it, and then we will validate that identity for you. We will validate the authenticity of that claim. I don't know if that was clearer or not, but that's what it is. OK, last point. We're going well. Instance concurrency. This is a bit of a difficult one. I'll spend a little bit of time on it. And the reason I want to talk about it is because it relates to Ben's demo that hopefully he's going to have time to do. So when we refer to an instance, we use it to mean a copy, if you like, or an instance of your functional service. And as we scale up your application, we're scaling up instances. When we say concurrency, we mean how reentrant is that service? How many requests can it process concurrently? So in a service like Cloud Functions, it has a mode of single concurrency, which means that every time a request comes in, we're spinning up a new instance of it. Now, that's for two reasons. One, it just makes the programming model much simpler. You don't have to worry about race conditions in your code because two requests are going to be competing over the same bit of data. The billing model is a lot simpler because you're just paying while a request is in flight, and if there's two requests, maybe that gets more complicated. But it has this negative side effect, which is that, particularly for web-style workloads, for a large part of the request execution time, the CPU is idle because it's I/O bound. You're waiting for network, or you're waiting for a database, or you're waiting for disk. And the CPU is idle. And during that idle time, it's not being used. The instance is hot. We're keeping the instance alive because it's waiting for this API to return, but the CPU is idle. And actually, a better mode is to allow that idle CPU gaps to be used by another request. This is what we mean by concurrency. And so in Cloud Run, we support concurrency. Cloud Functions is concurrency 1. Cloud Run is concurrency as many as we can jam into it. I think it maxes out at 80, but that would probably work for a hello world, but any reasonable application is going to get 5 to 10 concurrence. So it's not new. This has been around since the dinosaurs, but it's new for serverless billing models. And that's because it's not intuitive necessarily how it works, although it turns out it's not that complicated. So this is an instance, as I mentioned. The instance has an instance time. Now, the instance time is how long we keep it up for. Nothing to do with you. You might have 0 QPS, no requests going onto it, but the instance will still be there because we haven't killed it because another request might come in, so we keep it warm. But then there's the request time. The request starts and it stops at some interval. And in a service like Cloud Functions, you would pay while that request is in flight. You don't pay for the instance lifetime because it lives longer. In a case of a concurrent case, or for example in Cloud Run, another request might come in halfway through. Well, it's pretty simple. All we do is say, well, the billable time is the time between the start of the first request and the end of the last request. It's not that complicated, really. But it has big impacts. One, you have fewer cold starts. Why is that true? Well, every time a request comes in, we don't have to start up another instance. If there's an instance that has space to serve that request, we'll serve it on that instance. So you have fewer cold starts as you're ramping up. You can scale up a lot faster. Your QPS, if you have a massive Black Friday event or some news article gets published and you need to react very quickly to a massive spike in traffic, you can do that better with concurrency because you have fewer cold starts. And you get better utilization of the underlying compute. The only caveat is that you lose some of that simplicity of the developer model or the programming model, where you now do have to worry about concurrency in your code and sharing global state might be problematic. And that's not new. We've done that for a long time. It was sort of a luxury in the functions world, but we didn't have to think about that. That's one of the trade-offs. So we made it. I'm going to invite Ben on stage. Thanks. I'll get off.
Thanks, Jason. So today, I'm going to be sharing with you all the results of some work that we've been doing in Cloud Run to achieve really fast scaling. Give me just 1 second to get set up here. Fantastic. So as Jason talked about earlier, concurrency is something that's really great about Cloud Run applications. It allows you to handle multiple requests at the same time in an instance. And the other good thing about serverless products that Jason talked about earlier is the pay-for-what-you-use billing model. So if you don't have any requests, if you aren't doing any useful work, you aren't going to be charged anything. Our autoscaler will scale you up when you receive an increase in traffic. We'll scale you back down afterwards. But you won't be charged for pre-provisioning capacity. You don't have to worry about what's happening when your instance and your service is not doing work. So what I'm going to show you today is we're going to deploy a very straightforward app that just burns CPU for a second. And then we're going to send a lot of load at it and show just how quickly and how responsive the Cloud Run autoscaler is to changes in load. So this is my deployment command. I'm not a PM. I don't copy-paste this. I just ran it earlier this morning and already have it in my bash terminal. It's a very straightforward command. It's just like what Jason was showing you earlier. We've got an image that's stored in GCR. It will burn CPU for a second and then respond. And for the first part of this demo, we're going to set the concurrency to 1. So this instance can only handle 1 request at a time. We'll go through the deployment command. And if we go over here to my fancy monitoring dashboard, we should see an instance pop up here in just a second and then go away. And that's an instance that's serving a health check as part of the deployment request. Well, it's been deployed. So hopefully, if we refresh the monitoring dashboard, we'll get updates for the actual test. All right, there we go. Making progress. So the next thing that I'm going to do is I'm going to take my newly deployed service, and I'm going to send it a lot of load. So what I have to generate load today are 10 instances running in Google Compute Engine. And I'm going to have each of them send 1,000 concurrent requests to my new Cloud Run service. So this is a fairly long command that I have to do this. All it's doing is it's scheduling this work to happen at the top of the minute. And the reason I'm doing that, as opposed to just kicking each one off independently, is that we want all of this load to show up at exactly the same time. So if we go ahead and put that in and send it off to all of my load generators, then at the top of the minute, we'll see a large increase in load, and we'll see my instances scale up as well. One of the things that I want to note again is that right now, my service doesn't have any instances running. So there's no pre-provisioned capacity here. The Cloud Run APIs don't know that there's about to be a large traffic increase. But in just a couple of seconds here, we'll see how quickly they can react to getting 10,000 requests a second. All right, there we go. So it took less than 10 seconds, and we've got 10,000 instances now that are running live in Cloud Run, that are burning CPU, that are responding to requests. We're serving 10,000 QPS. So this is really cool. This is really powerful. It doesn't matter how much load you want to throw at Cloud Run. It doesn't matter how quickly it will show up. It doesn't matter that it comes out of nowhere. We'll be able to serve it and run your service for you quickly. But once again, you're only paying for what you use. So this load test is going to wind down here in another couple of seconds. The number of instances will drop back down to 0. And at that point, I, as a customer, won't be getting charged anything. I don't have to worry about the fact that I just spun up a bunch of revisions. I'm now doing absolutely nothing. We go back to 0, and my bill from this point onwards is also 0. So that was fun. But we just talked about the benefits of concurrency and how with concurrency you can generate even more load and do more useful work. My application is very straightforward. It just burns CPU. But for apps that do have downtime, it's useful to be able to process multiple requests at the same time. So what I'm going to do now is I'm going to redeploy the same application, but I'm going to double the concurrency. So I'll allow each instance to handle 2 concurrent requests at the same time. So we'll go ahead and deploy the new revision. And one thing I should note as this is happening is that Cloud Run does not share instances or any of the underlying code or container between deployments. So even though the only thing that I'm changing is the concurrency, for security reasons, we're going to be removing all of the old instances. And once again, I'm going to be scaling from 0 here. So we'll take the same load generation command, but we're going to, because we now have 2 concurrency, double the amount of load that we're sending. So I'll have each of my 10 compute engine instances send 2,000 requests per second at a time for a total of 20,000. And what we'll expect is that that will give us still 10,000 instances, but with twice the throughput capacity. So just like before, this will kick off at the top of the minute. And if we refresh the monitoring dashboard, it should happen here in just a couple more seconds. We're back up to 10,000 instances. And as you can see, the request per second is not quite 20,000. It looks like there's a bit of an issue with my load generation code. But we've got 10,000 instances. We've got almost twice the throughput that we had before. And that's the power of concurrency. With the same number of instances, the same number of cold starts, we're doing twice as much work as we were before. So I've shown you the power of the rapid scaling that Cloud Run's infrastructure has. But I want to talk about a couple of actual use cases where something like this might be useful. So the New York Times runs their crossword puzzle on App Engine Standard. App Engine is one of our serverless products, but because of some issues with its billing model, the scaling is a little bit slower. It happens on the order of minutes instead of going up to 10,000 instances in a few seconds. What that means is that when the New York Times publishes their new crossword for the next day at the exact same time to every single one of their users, they need to worry about pre-provisioning capacity, making sure that they have enough pre-warmed instances that they can send all of their information out quickly. With something like Cloud Run, you really don't have to worry about that at all. Another example is Snap, who runs a lot of their compute workload on Google Cloud. Snap does continuous delivery on their main services, or continuous deployments on their main services, which means that they're traffic splitting between multiple different versions multiple times per day as they're continuously pushing out new revisions. With traffic splitting for high traffic services, you need to spin up lots of instances very quickly to handle the new load and spin down other ones. With scaling like this, you'll be able to do that very quickly and seamlessly without any latency or lag for your users. Thanks very much.
Thanks, Ben. I've seen that demo several times now, but every time I see it, it still blows my mind that we're spinning up 10,000 instances of your app in like 5 seconds or so. OK, that's it. We're done with 42 seconds to spare. Again, reminder, rate the app honestly or 5 stars, whatever you like. And if you want more information, those URLs, my Twitter account, it's not that interesting, honestly, but there it is. Thanks very much.